When we have a geometric series and we want to find the sum, if it's just a couple of terms, it isn't too bad just writing it out and adding them up. However, if we have to go out pretty far on a geometric series, we don't want to write out each term, like 20 terms, 50 terms. We don't want to write each of them out. So we want to use one of the sum formulas, and which one you use will depend on what information you have available. So if you're given the first term is easy to find because it's your first term. But if you don't have your nth term, you'll want to use the first form of the formula because we just have our first term and our ratio. So either way, you're going to need your first term and your ratio. If you don't have any of the other terms, you'll want to use the first form. If, however, you do have your nth term, you'll want to use the second form because it's a little bit easier to work with. You don't have to take your ratio to a power. So that's really not too bad. So if you don't have your nth term, use the first form. If you do have the nth term, use the second form. So let's look at an example where we have to use the first form. So here we have a geometric series and k equals 2 to 20, and we want to add each of these terms. So our first term, our k starts at 2. That's okay. K equals 2, so our first term is 1 over 3 squared. Our second would be 1 over 3 cubed plus all the way up to 1 over 3 to the 20th. Now this actually wouldn't be too bad to find because we know what our nth term is. It's 1 over 3 to the 20th, so we could find that. But how do we know what our r is? Our r is just, if you think about it, 1 to the k is 1. 1 equals 1 to the k. No matter what power we take 1 to, it's always going to be 1. So our 1 over 3 to the k is the same as 1 to the k over 3 to the k. So that means our summation, 1 over 3 to the k, is the same as, wow, that's a funky looking summation symbol, is the same as 1 to the k over 3 to the k, or you can also write it as 1 over 3 to the k, and we still have our k equal 2 to 20. So our ratio in this problem is r. So now we know our r, and so now we can use our formula. We could use the second form because we know what our nth term is, but I would rather use our first form. Now for this one, since k starts at 2, our n is really k minus 1 because our first term is when k equals 2. So let me erase some of this. And so let me mention that again. Our n equals k minus 1 because when k equals 2, n equals 1. K equals 3, n equals 2. So it's just 1 less. So it's really not too bad. So what we really need to remember, so we have k equals 2 to 20, parentheses 1/3 k R equals 1/3, N equals K minus 1. Okay, now we also want our formula. So let me grab that, and we can plug in everything that we know. So the sum of S sub n, well, n is actually 19, equals A1, which is 1/9, because that's this term, this is A1, times R to the n, make sure that looks like a 9, R to the n, R was 1/3, n is 19, minus 1, this should be in brackets, all divided by 1/3 minus 1. So all we have to do is evaluate this, which for this one in particular, because we have 1/3 to the 19th power, I'm going to use my calculator. 1/3 to the 19th power minus 1. And then I'm going to multiply that by 1 divided by 9. I'm going to use parentheses to make sure that I get everything in the right place. So I have on my numerator -0.1 forever. And then on my denominator I have 1/3 minus 1, which is -2/3. So I'm going to write it -0.6 forever. So I have two negatives make a positive. So it's going to be a positive answer for my sum. And then I have 0.1, which is 1/9 divided by 2/3, because I happen to know these fractions. You could also write this out and it would probably be a little bit better. So you're going to get 0.16 forever. And if you need to round it somewhere, you round it appropriately, but you have the 0.16 with the line over top. I hope this helps you with this simple geometric problem, simple in relative terms. And if you have questions, let me know.